Okay, this is my explanation of the work for assignment 16. You all seem like you got 32 through 35, so I'm not going to explain those. Those are pretty straightforward. So we're going to start at number 36. Okay. Now, remember, before you can add them, the radicals have to be identical. Okay? Whoops, I got it down a little too far. Okay. The radicals have to be identical. Now, I could take 5 and multiply it by something to make it 625, but ideally, you want to break down the 625 so that we have the radical as small as possible, okay? So, since this is a 5, we know that we can probably divide a 5 into this, okay? So you start by just copy down the 6 cubed root of 5 plus 4, and then take 625, divide it by 5, you get 125. Now, the reason that we like this cubed root of 125 is because it is on our list of x cubed. When you go down here, you see 125, so that it will become the whole number 5. That's the whole point of doing it. Okay, so now I've just copied this down. This we just said becomes 5. And I've got this. Now, this was the whole goal, that we would have the same identical radicals. So now all I have to do is multiply the 4 and 5. So now my problem becomes 6 times the third root of 5 plus 20 times the third root of 5. So I just add the 20 and the 6 to get my final answer. Okay, 37 is the same type of problem. We've got a 7th root of 2 and a 7th root of 256. So we want to turn this into a 2 if we possibly can. All right, so we're going to start by taking 256 divided by 2, and we get 128. We like the 128 because when you look on our x to the 7th, we see 128. Okay? Now, if when we divided by 2, we didn't see a number, we'll get that later. But we like this x to the 7th, the 7th root of 128, because we get 2. Whew. Okay, so I change this to 2. Multiply my 2's, I get 4. So the problem becomes negative 6, 7th root of 2, plus 4, 7th root of 2, equals negative 2, 7th root of 2. Okay, 38, working the same way. Got 2 and 512. So we're going to try taking 512 divided by 2. We get 256. So we check our x to the 4th list. X to the 4th, 256 is on there. So that's good. That's what we want. Because now these are the same, and this one becomes a whole number. So it becomes 4. Multiply the 7 and the 4. You get negative 28. Notice I've just brought all these down. So now this is my new problem. And I get negative 16 to the 4th root times 4th root of 2. Okay, number 39. If we try to turn the 1250 into a 32. Okay, so I'm going to take 1250 and divide it by 32. And what I get is a decimal. So that's not going to work. Okay, so I could take and multiply both of them, but that's just going to make them both bigger. So what I'm going to do is I'm going to see if I can make them smaller. Okay, can I take something on the x to the 4th and divide it into both of these? Okay, so let's start with the 32, because that one's going to be easier to see. So we're going to go to our x to the 4th column. Okay, now the numbers get real big real quick, so we're pretty much just looking at 16 and 81. Can we divide 32 by 81? No. So that leaves us with 16. Can you divide 32 by 16? Yes. 32 divided by 16 is 2. So my 32 became 16 and 2. This one's important because it's on the x to the 4th list. Now that's the smallest. So I'm going to go here and see, can I divide that by 2? Yeah, it ends in 0, so it's definitely going to divide by 2. Okay, so divided by 2, I get 625. Go back to my x to the fourth list, and I see 625. Okay, so my 625 becomes 5. Keep the fourth root of 2, keep my whole number 2, keep my negative 8, my fourth root of 16 becomes 2, keep my fourth root of 2. Now I just multiply the whole numbers. So I have 10 and negative 16. When I add 10 and negative 16, I get negative 6. Okay, we're going to try the same thing with number 40. Okay. We're going to see, can you do 750 divided by 48? Nope. You get a decimal. So we're going to go to our x cubed list and find out what number on here we can divide 48 by. Okay, I can't divide 48 by 27, but I can divide 48 by 8, and I get 6. Okay, so that's just working on simplifying 48. Now that tells me what to do with the 750, because I'm going to want to keep this 6, right? Because the 8 is on my list. It's going to become a whole number. This isn't going anywhere. So I want to see, can I do 750 divided by 6? And I can. I get 125. And when we look at our x cubed list, 125 is right there. So my cubed root of 8 became 2. My cubed root of 125 became 5. Multiply the 5 and 2 and I get 10. Bring this down. My radicals are identical. 10 minus 5 is 5. Okay, so now on number 41, they tell us that they did something wrong, and what they did is they added the radicals. Remember, the radicals, you can't add them. They have to already be identical. So they had to change them. Now, the difference with this is I could simplify 10 to 5 and 2. The problem is that when I look at my x cubed, I don't have a 5 on here, and I don't have a 2 on here. So I can't actually simplify the cubed root of 10. I can only simplify it if it's one of its factors is on this list. So when neither one of them have factors on the list, that's when you have to multiply them by each other to make them identical. Okay? So I multiplied the cubed root of 10 by cubed root of 5, multiplied the cubed root of 5 by cubed root of 10, so I get the cubed root of 50. And now I can add those. Okay? And it still works because my cubed root of 50 is not on my x cubed list, and there's no factor of 50 on here. So it can't be simplified. That's it. That's the answer. Okay, 42. Let's see, what did they do? Oh, they tried to turn the bottom into a y cubed, which is what they need. But when they multiplied the bottom by y to make it y cubed, they had to also multiply the top by y, so that they end up with the third root of xy over y. Hopefully that answers your questions. Let me know if you have any more. Thanks.